Assalamualaikum warahmatullahi wabarakatuh. My name is SYAFARIEZA binti EFFENDI and my student ID is 2023299292. So for this video, I will present to you about my second assignment, which is for subject CSC508 data structure. So for this assignment, I create a system called Formula 1 inventory system. So for this one, I create this system by using stack and also queue, but not only that, I also provide an infix to postfix conversion. So without further ado, let's just jump into the system that I've created. So now I'll show you all of the class that I've created for this system. So the first one is a queue class that I name it as F1Q, which is extend from the class linked list. And then there's a few methods right here. So the first one is the NQ method, which is to insert data, and then DQ method, which is to remove data, and then get front, which is to get the first element from the data structure from the queue, and then get end, which is to get the last element from the data structure, and then is empty, which is a very useful method to check whether the data structure has which is empty or it has an element on it. So the next class that I've created is a stack class that I name it as F1 stack, which is also extend from the class linked list, and there's a few methods right here. So the first one, it has a push method, which is to insert data, and then pop method, which is to remove data, and then pick, which is to get the first element from the data structure, and is empty, which is also the same as the queue class, which is very useful to check whether the data structure is empty or not. So now I'll show you the next class, which is the Formula 1 inventory class. And then we have a few attributes right here, which is parts ID, part name, category, quantity, team, and also unit price. And then we have the default constructor here, and then we have the normal constructor, we have setter, and also getter. And we have method to calculate the total price, and also toString, which is a method for displaying details. So now I'll show you the infix to postfix class, which is a special class to convert infix expression to postfix expression. So firstly, I create a class. As you can see, the name is infix to postfix, and then I define a method, which is it will take an input string, which is an infix, and then return the converted, which is the postfix string. And then I use the string builder to build our postfix result, and a stack to temporarily hold the operators and also parentheses. So there's a for loop right here. So we loop through each character of the input string by using this loop, and then we have if statement right here. So the first one, if the character is a letter or a digit, we just have to add it directly to the postfix string. And then if it's an opening bracket, so we just have to push it to the stack and mark the beginning of the sub expression. So if it's a closing bracket, so we just have to keep popping from the stack and adding it to the postfix string until we reach the opening bracket. So for this one, so if we find an operator, so we check if it has like a lower or equal precedence than the top of the stack. So if so we just have to like pop from the stack to the postfix string and then push it to the new operator. So there's a while loop right here. So if the loop ends, so we just have to pop any remaining operators from the stack and add them to the postfix string, and then we just return the full postfix expression as a string. So there's a method right here So this method to check whether the character is an operator or not. So there's another method which is to give each operator a precedence value. So for example, the plus minus sign has a lowest precedence, right? So it will return a number 1. So for the mid one, which is multiply, division, and also modulus sign, so we just have to return number 2. And then this symbol and also the $sign symbol, so it has like a higher precedence value compared to the other one, so it will return a number 3. So now I'll show you the main class. So firstly, I import some of the Java package, and then I create a scanner object for user input, F1Q object for F1Q class, and F1S object for F1stat class. And then we try to read the data from the file called f1inventory.txt, and then we read the file line by line by using a string tokenizer, and then we split each line into a token according to a semicolon. So there's a few attributes right there, and this attribute will be inserted back into the object name F1IMV that I've created for Formula 1 inventory class, and this object will be inserted into the F1Q class and also F1S, which is stat class. There's a catch right there to handle error if there's a missing file or invalid data. And then there's a while loop right there. So the user will choose a menu so that the user must choose each options. So if the user enter 10, then the loop will end. And then let's go through each option one by one. So if the user enter 1, this is where a list of Formula 1 inventory record will be displayed. So I declare an object name as them, which is F1stat class, and then a variable name list to store the list of Formula 1 team inventory records. So while stack is not empty, so we will pop all of the data from the stat class, and the data will be inserted into the variable name list to keep the details of the Formula 1 inventory records, and then we will push them back to the stem object that I've created earlier. So after all of the loops is end, after it will retrieve all of the data, and then the final variable list will be pop up in show in scroll pane. So if the user enter 2, so this is where our user can search for a specific Formula 1 team name. So I declare object name temp_s for F1stat class, and then I declare variable search that store a Formula 1 team name that the user want to search. So there's a while loop right there. So it will retrieve the data from a stat class. Now they will check if the data from the stat class is equal to the search, which is a specific name for Formula 1 team that the user want to search. Now the found is changed to true, and then the result will be stored into a variable name result, and then the data that we popped earlier from the stat class will be pushed back into the temp_s object. Now the result, variable name result, will be show up in a show in scroll pane manner. And then if the user enter 3, this is where the user can enter a new data. So for each attribute, the user must enter each one of them, and then this data will be inserted back into the F1Q object and also F1S object, which is to a Q class and also stat class. If the user enter 4, so this is where the user can search for parts ID, enter parts ID that they want to delete, and it will be stored into a variable named parts ID delete. So I create an object named new Q object and new S object, and then for while, there's a while loop right there. So if the Q class is not empty, it will be retrieve data from the Q class, and it will check if the data from the Q object is equal to the parts ID delete, and the found is equal to true, and it will show a message which is delete from queue, and then the data that we dequeue earlier from the queue class will be inserted back into the new queue object. And then there's another while right there. So if while the step class is not empty, we will pop data from the step class, and then we check if the data from the step class is equal to the parts ID delete, and then if it's equal, then found is equal to true, and then there's a message pop up delete from stack, and then the data that we popped earlier will be pushed back into the new S object. Now if the user enter 5, this is where the calculation of for each Formula 1 team and also the grand total price. So I declare an object QTEM for F1Q class, and there's a while right there. So if a Q class is not empty, we will retrieve the data from a Q class, and there's a calculation right there to search for each Formula 1 team and also the grand total price. And then the data that we dequeue earlier will be enqueue back to the QTEM object, and then we will display all of this output into this kind of manner just to keep it organized. And then if the user enters 6, this is to search for a lowest total price. So we will create QTEM object and also STEM object, and then there's a while loop right there. We will pop the data from the stack class, and then there's an operation right there to find the minimum total price, and the data that we popped earlier will be inserted back into the STEM object and also QTEM object. So and then the data, which is the minimum total price, will be show up in this J option pin show message dialog manner. And then if the user enters 7, this is to search for the highest total price, and then I create QTEM object and also STEM object. So there's a while loop right there, and then if the Q class is not empty, and then we dequeue the data from the Q class, and there's an operation right there to find the maximum total price, and then the data that we dequeue earlier will be enqueue back to the QTEM object and push back to the STEM object. And then the final data that we found in the operation will be pop up in that J option pane show message dialog manner. So if the user enter 8, this is to search for the average price, and then we create STEM object, and while stack is not empty, and then we pop data from the stack class, and there's an operation to find for calculate total price and also count plus for each data, and then the data that we pop earlier will be inserted into the STEM objects. So the average price that we calculate will be show up in a J option pane show message dialog manner. And then if the user enter 9, so the variable name infix will store the mathematical expression that the user want to convert, and then it will send to a method, to a class infix to postfix, which to convert infix to postfix, and then the postfix expression will be pop up in the J option pane dot show message dialog. And if the user enter 10, that means that the loop will end, so it will shows a message, thank you for using these systems. So if the user enter other than 1 to 9, then there's a message called invalid menu option. So please enter a number between 1 and 9. So we close, and then there's a class right there for a show in scroll pane, just to make the output to make it very organized. So now I'll show you the output. So first we enter 1, and then all of the Formula 1 inventory records will be displayed. So as for now, I have 20 records. and then we enter 2 to search for a specific team name. So for example, I want to search for McLaren. So all of the McLaren's record will be displayed. Okay, so we enter 3 to add new records. So for example, I want to add for Williams. Parts ID P021, parts name, brake parts, brake for category, quantity 3 and 350 for the price. So let's view the record. So the new records has been added. Now let's delete the records. So we enter P021 and then let's view the record again. So the new records that we added just now has been deleted. And let's view the total price. And then lowest total price, highest total price, average. So 9 is special for infix to postfix conversion. So for example, I want to convert A plus B multiply C. So this is the result. And then 10, we exit from the system.